Okay, Unit 3, Day 4a, we're going to look at properties of logarithms. So, on Day 3, we evaluated them, we graphed them. Now we're going to do some properties with them in ways that you can change them to make them easier to solve, and also when you get to calculus, it might make it easier to do some things that you do there. So, our first learning target, I can use the properties of logarithms to expand and condense. You probably remember those words, and possibly it brings a little bit of anxiety to your thoughts. So that's okay. We'll figure it out. I can use the change of base formula to evaluate logarithms. Now this is really cool. If you remember, that makes it possible for us to evaluate any logarithm, not just the ones on our calculator. So that's a really cool one. Most people like the change of base. Now remember, logarithms are exponents, so they're going to behave like exponents. So recall these over here. Okay, so if I have b to the x times b to the y, if they're the same bases, you add the exponents. Okay, so you add the exponents. If you're dividing, so same base, but you're dividing the top one, so it'd be, you would subtract the exponent. So if you're dividing, subtract exponents. Remember, an exponent is a logarithm, so at some point, we're going to, instead of saying add exponents, we're going to say add logarithm. Okay, but these are exponents over here. If you've got a power to a power, you're going to multiply them. You're going to multiply the exponents. So over here, looking at it a little bit differently, here we're multiplying. Well, here we're also multiplying r times s. So anytime you're multiplying, you add the exponents. Well, here we're going to add the logarithms. So we're going to write them as two separate logarithms with the same base, but we're going to add them together. So we're going to split r and s apart, give them their own logs, and then add them together. Here we're dividing. Dividing means subtract, so this we're going to subtract the logarithms. A logarithm is an exponent, same thing, right? Now here, c is an exponent for r, while log base b of r is also an exponent because it's a logarithm. So you're going to multiply the exponents together. The exponent c times the exponent log r, log base b of r. So you're going to multiply them together. So you're actually multiplying the log and the exponent. But the logs, basically, logs / exponent. The logarithm and exponent are the same thing, so that's why it's multiply. Okay, so now here's just some quick examples. Expand these. Okay, I'm multiplying. That means I'm going to write 2. So log base 2. A goes on one, B goes on the other, so we split them up, give them their own logs, and the operation that goes between them is addition. Okay, so maybe try the next couple here. Let's do B, C, and D. Okay, try these out, and then I'm gonna pause the video. I'm gonna write them in real quick. I want you to pause them and try them out. Quiz yourself, see if you remember how to do this. Okay, so the first one here, pretty straightforward. It's division. So you're going to give them each log base 3 of C, log base 3 of D, but it's going to be a minus between them. Over here, this 3 is an exponent of y. So it's only an exponent of y. So we want to split those with addition first, with the 3 being on the y. So log base b of x plus log base b of y to the third, and then I move the 3 up. I did it all in one step. Now that is different than over here. Look at these two. The big difference is here, the exponent is on the y. Here, the exponent is on x and y. Okay, so what I'm going to do, I'm going to pull that 3 up front first. So it'll be 3 log base b of xy. And now it's actually, think of it like this. It's going to be 3 times both of them. So when I expand it with a plus, they both get a 3 out front. Okay, so that's the difference. If it's the exponent of a whole argument, it's going to go out front early and it's in front of everything. If it's like this, it's just going to go in front of the log that has a y in it. Okay. Letter E. Study that for a little bit here. What can I do with that? Okay, maybe you're looking and hopefully you didn't initially think, oh, it must be multiplying together. I can multiply. No, this one's nothing. So nothing you can do with that. That's it. That's all you can. That's all the more you can expand. This guy here. Let's get a little crazy here. So first, I would let's see, log base b of x. And then that 2 is going to come out front, plus, because these are being multiplied together, log base b of, and instead of the cube root of q, the cube root of q, I'm going to put q to the 1/3, but then put the 1/3 out front. Okay, and now divided by would be subtract. So I'm supposed to subtract log base b of y. And now this would actually be plus, but I'm subtracting both of them because I'm dividing by all of this. So it's like subtracting that whole thing. So I'm going to distribute the negative out, put another minus there. Log base b of t. Now that'd actually be t to the 1/2 power. So I'm going to pull the 1/2 out front. Okay. That took a little bit more space than I wanted. You do something like that. Okay. This guy here, the exponent is on the x, so the natural log that gets x is going to have a 2 out in front of it. So it would be the natural log of x squared, put the 2 out front. Divide means minus. Natural log, should left space there, y to the 3rd, which means it's going to be a 3 out front. So minus, so it'll be 2 natural log of x minus 3 natural log y. Maybe I'll put a little nicer down here. Okay. Over here, look at this. Log, just says log. What's the base? Well, if it's not written, it's 10. Okay, this one was e. I didn't say that. Natural log, the base is e. But here the base is 10. And I'm multiplying these two things together. So it'd be log 1000 plus log x to the 4th, put the 4 out front. Now the thing about this, I can simplify this. If this is a 10, that means 10 to what power equal 1000? That's going to be 3. So it'd be 3 plus 4 log x. So sometimes you can simplify it a little bit further. This one had a number in it. The other, all these up here were just variables. So that's why we didn't do them. We didn't have to do that sooner. But here, those had a number, so I could do it. Condense is the exact opposite. I want to slam everything together as much as I can. Okay. So if I'm adding these common logs, well, I could just write one common log and then xy. Maybe some of you looked at this, you're like, oh, I like this way better. Oh, I love condensing better. I don't love expanding, but there is a time and place to expand, believe me. And when you get to calculus, there is a time and a place where you do want to expand and make your life easier. But most people like condensing a lot more. Now, these are all log base 2s. That means I can put them all together in one big log base 2. But I've got x minus y minus z. So that'd be the same thing as x minus y plus z. Think of it that way. So this would be x on top divided by, and then y and z are being multiplied together. Because these are actually, think of it as being, they're both being subtracted, they're both being divided, or you think of it as being multiplied together. Okay, next guy. Now, if you notice, this 1/3, this is considered expanded because it's out front. So to condense, I need to put it back up into an exponent. A lot of people look at that and say, I don't understand how that's any different. That's just how it is. That's how we say it's condensed if it's in the exponent. We say it's expanded if it's out front. So this would be log base 5 of x to the 3rd, which is the same thing as a cube root. So we say this is condensed all the way. Down here, both common logs. So I can write one common log. This could come up here as a 4, y to the 4th, so it would be y to the 4th, minus means divide, so common log of y to the 4th over z. This one's going to get crazy here, so let's kind of split these up. This 3 would go up here as a 3rd power, this would go up here as a 2 power. So it would be natural log of x cubed y to the 3rd times y z squared to the 2nd. Okay, now let's simplify some of that. So this x to the 3rd power would be x to the 9th, y to the 3rd, y squared, z to the 4th. And this would be x to the 9th, y to the 5th, z to the 4th once you're all done. Okay, all right, let's flip this guy over. The change of base formula is kind of, I think it's awesome. It makes it possible for us to do a lot of different things. So if you remember, our calculator will do common logs and natural logs. So if you remember, you got your common log button and your natural log button. That's great, but what if you have a logarithm that's not base 10 or base e? Well, there's this cool formula. It's called the change of base formula. And it says that you can, if you have log base b of x, take that x, make it the argument of the top, take that b, make it the argument of the bottom, and you can pick any base you want. And it just says a. It can be anything. Now, the smart thing to do would be let a equal 10 or e, because then you can let your calculator do it. So we can convert these to natural and common logs. So you can let a be any base, but since your calculator can do logarithms with base a and e, let's use that. Let's do common natural logs. So evaluate these using change of base. So if I wanted to convert this to change of base, I could either use the common log of 7 over the common log of 2. That's actually going to equal the exact same thing as a natural log of 7 over the natural log of 2. It's really cool how it works. It would also equal the log base 12 of 7 over log base 12 of 2. But my calculator doesn't do base 12, so I wouldn't do that. So type it in your calculator, you get about 2.807. That's supposed to be a 7. When you're done, check your answer. So how would I check that? Well, what I just found, I'm saying that this equals 2.807. So that means 2 to the 2.807 power should equal 7. Okay, type in the calculator, I got 6.998. That's close enough. So that definitely worked. So check. This guy here, again, log 19 over log 5. You could use natural log 19 over natural log of 5. It's up to you. There might be certain situations where you would have a preference, but 9 times out of 10, it doesn't matter which one you use. So this one equals 1.829. That means my calculator, or I am claiming that 5 to the 1.829 power equals 19. Type in the calculator and I get 18.985. So that one was close enough. Okay, so try the next one. Pause it and try the next one, see what you get. Okay, so I used natural log on mine just to try something different. I got a negative, and sometimes you think, oh, negative, something's wrong. Remember, this is an exponent. It's okay for an exponent to be negative. So I got 0.5, which is a fraction. Now, the only way I can get a fraction raised to a power to become a big number like 12 is if I flipped it over. So this is 1 over 2. Well, if you take it to a negative now, it's 2 over 1 to the 3.585 power, and that is about 12. It's like 12.003 or somewhere in that area. Now don't be concerned if your decimals are slightly off from mine. If you're close to 12 and close to 19 and close to 7, you're good. You're doing it right. Okay, at the bottom, so evaluate the given two other logarithms with the same base. So we're going to tell you that log base b of 2 equals 0.6309 and log base b of 5 equals 1.4650. And we're not telling you what b is, so you have to use these to solve. You can't just type into the calculator and find it. Well, what I want to do is I want to write 10 as some sort of combination of 2 and 5 with different operations, whatever operations it takes to use 2 and 5 to get 10. So maybe you're thinking 2 times 5. Well, I could write this as log base b of 2 times 5 instead. Then that'd be log base b of 2 plus log base b of 5, which would be 0.6309 plus 1.4650. Add those together, you get 2.0959. And that's our answer. The next one, 0.4. How would I get 0.4 using 2 and 5? I think 0.4 is the same thing as 4/10, which is the same thing as 2/5, 2 and 5. So log base b of 2 over 5 would be the same thing as log base b of 2 minus log base b of 5. So this would be 0.6309 minus 1.4650, which is negative 0.8341. So give these two a try. Pause your video and actually pause it and give them a try and see what you can do. And then if you get stuck, you can always hit play and I'll have the answers up in a moment. Okay, so here's the rest of it. Hopefully you gave it a try. What I did is 50 is the same thing as 2 times 5 squared, 2 times 25 or 5 squared. If I split these up, I'm going to take that multiplication, make it a plus, take that 5 out front as a 2, and then it would be 0.6309 and then 2 times 1.465. Think of it this way. There's your answer. 25, 30 seconds. Think of that as 5 squared on top and 2 to the 5th on bottom. You can kind of see the rest of there, split it up. Okay, so if you have any questions, please let me know.